Hey guys, welcome back. In this video we're going to look at abstraction, one of the OOP principles, following on from our last video where we looked at inheritance. If you haven't seen the last video on inheritance and you don't already know all of the joys of inheritance, at least when it comes to programming, I'll put a link in the description where you can check that out. But in this video we're going to focus on abstraction as it relates to OOP. So the basic idea of abstraction is taking some information or taking some decision making that's in class A and abstracting it out and putting it into class B. And class B usually will be a child class of class A. So the example that I'm going to use here is, let's just say that Mario is a little bit quicker than Luigi. So when Mario moves, he moves by a little more than what how much Luigi moves. So currently both of them, whenever they move, they increase their x coordinate by 20 pixels. And it's constant, it's fixed between both of them. But let's say Mario moves by a little more than Luigi. Let's say Mario moves by 30 and Luigi moves by 20. Well, one way that you could try to solve this is inside the move function, we could ask ourselves, is this Mario or Luigi? And adjust, that value, either 20 or 30, based on this decision making inside the parent class. But that's a little messy, and we could end up with 50 different child classes. We could have Mario, Luigi, Wario, Yoshi, Peach, and it would get kind of crazy, and this function would end up ballooning out, and it wouldn't look great. So a better idea is to abstract that decision making out, abstract this value out of the parent and move it into the child. So what we can do is, for starters, let's address one problem. One problem is I can actually create a new instance of a player base, and I don't really want this to happen. I want you to only be able to create an instance of a child class. I don't want you to be able to create an instance of the parent. So to deal with that first, I'm going to make this an abstract class, since we're talking about abstraction. And let me just bring that back. Now, because I've added that keyword, you can't do this anymore. It says you cannot create an instance of the abstract type or interface player base. So great, now this is an abstract class, and I'm forcing everybody to use one of the child classes directly, which is good. That's what we want. Now let's address that problem. We've got this value here, 20, and we want to abstract it out. So I'm going to use this abstract keyword again. I'm going to say we want a protected abstract integer speed, and I'll call it, I'll initialize it to 0, or perhaps instead of speed, I'll call it maybe get speed. And then instead of using 20 in here, I'll just use this dot get speed. And now we don't have to worry about this decision, is this Mario or Luigi, because it's been abstracted. And both Mario and Luigi, and if we add Bowser, Peach, and so on later, each of them need to specify this value that we've abstracted. So we can get rid of this check. And you can see Mario and Luigi are now complaining. It's saying Mario does not implement inherited abstract member player base.get speed, which is this. So notice that this is a function, but I haven't actually provided a body. I haven't provided, curly brackets and an implementation. And that's what makes it abstract. We're saying, I'm not providing an implementation, I'm leaving that, I'm abstracting that out, and it's now up to the derived classes, it's up to the child classes to provide this value. So what we can do is whenever you implement an abstract function or an abstract thing in a child class in C#, you start with the override keyword. So I'm just going to type override and hit space, and it comes up with all of the things that I can override. The one that I want to override here is get speed, and it will default to this throwing a not implemented exception, but let's not get into exceptions. That's a topic for another video. All we want to do here is for Mario, we want to return 30. So I'm being a hipster and I'm using the lambda function. I could have just returned 30 here. I only highlight that if there's anybody watching this who doesn't like the hipster programming with the fat arrows. All right, so let's do the same for Luigi. So I'm going to override get speed, and I'm going to return 20. And now let's come back to our program. We've got Mario and Luigi. We've got the color. We don't really care about the color now. We've already verified that that works. So what we might want to do is, you know what? Let's, instead of making this protected, perhaps let's make this public. So the difference between public and protected is something that's protected is only accessible from child classes or derived classes. So Mario and Luigi can both access this field. But if I wanted to access get speed from out here, it's actually not visible. But I'd kind of like to print it out just so that we can see what's Mario's speed and what's Luigi's speed. So I'm going to make it public. In practice, it's probably best off left as private, but I want to expose it. So I'm going to make it public. And I need to change this to also public and change this to public. Whenever you override something, it needs to be completely consistent, including the access modifier. So let's come back, and I'm just going to say console.writeLine Mario's speed, Mario.getSpeed, and then I'm going to say Mario speed, Mario X. I'm going to need to do a similar thing. Let's just say public int get X. There is another way that you can do this in C#, but as said, I don't want to get too deep into the C# syntax in this video. And we're just going to return player X. All right, Mario.getX, and then I'm going to say Mario.move, and then I'm going to say console.writeLine Mario's new X, Mario.getX, and I'm going to do the same thing for Luigi. Now, I really would like to use another OO concept here called polymorphism so that I don't have to copy this, but I'm unfortunately or fortunately saving that for another video. So for now, I'm going to be lazy and copy it. And change this to Luigi. All right, that looks good. Yeah, let's do it. Okay, let's run this. So we can see here, Mario's speed is 30, his original X is 50. After moving, his new X is 80. Is that right? Oh yeah, well, I guess I didn't have to do this because whenever you move, it does actually tell you the new x, but yeah, that's fine. Luigi's speed is 20. Luigi's original x is that right? Oh, my bad. Let's rerun this. Yeah, Mario's speed is 30, his original x is 50, his new x is 80. Luigi's speed is 20, his original x is 50, which matches Mario. His new x is 110, does that sound right? Wait a second. Oh, I've forgotten to adjust this. See, this is why copying and pasting is not a good thing. All right, let's try that again. All right, Mario's speed 30, original x is 50, new x is 80, 50 plus 30, so that sounds good. Luigi's speed is 20, which is what we want. Original x is 50, 50 plus 20 is 70, and his new x is 70. So that all looks great, and we've allowed Mario and Luigi to have different behavior, and we've abstracted that decision making of, what's the speed of, what should the speed of Mario be, what should the speed of Luigi be. We've abstracted it out of the base class or the parent class and moved it into the child classes using that abstract keyword. So there are different variations of this depending on the programming language that you're using. They can be more flexible and less flexible and give you different sorts of options when it comes to these OO features. But again, I didn't want to get too deep into the C# side of things. I just wanted to cover the OO principles. So that is abstraction. Alrighty, I'll wrap up here and I'll see you in the next video for polymorphism. See you soon.